Imagine trying to build, say, a skyscraper, maybe a huge bridge, or even like a sprawling airport terminal.
Yeah, massive project.
They're the ultimate team sports, aren't they? You've
Okay.
got architects, engineers, construction crews, suppliers, regulators, just tons of people.
All needing to contribute to one super complex, often totally unique project.
And the amount of information involved,
Yeah.
it's staggering.
Yeah.
Plans, specs, contracts, everything.
Uh-huh.
The biggest challenge is keeping absolutely everyone on the same page.
Yeah, that's the kicker.
Making sure they're all working with the latest, the most accurate information.
Right, the right version, no mistakes.
So for these huge undertakings, how do you actually tame this information explosion? How do you get that, that crucial single source of truth?
That is precisely the challenge that the Common Data Environment, or CDE, was designed to tackle, specifically in the AECO industry.
Right, architecture, engineering, construction, and operations. Most of you listening probably know that one.
Exactly. And there's actually a standard, ISO 19650, that really nails down its purpose. It calls a CDE the agreed source of information for any given project or asset,
Okay.
for collecting, managing, and disseminating each information container through a managed process. So basically, one central, trusted hub for everything.
That definition really, really solidifies it. One trusted place.
Yeah.
And our mission today in this deep dive is, well, to break down exactly what a CDE is.
Yeah.
Trace its pretty fascinating journey, from paper, actual paper, to digital dominance.
It's quite the evolution.
Understand why it's now such a critical standard and maybe even peek into its future.
Sounds good.
And all our insights today, just so you know, come from a great article by Paul Markovitz, Virginia Senf, and Matt Keene. It's called, What is the Common Data Environment, CDE, and why is this important to the AECO industry?
A really solid piece.
Okay, so let's unpack this. Let's start right at the beginning with what you could maybe call the original common data environment.
The paper era.
The paper-based era, exactly. It almost seems quaint now, thinking about it, before digital files took over. But what were the core challenges back then? Do they still echo today, even with all the digital stuff?
Oh, absolutely. It's a great visual, actually. Paul Markovitz, one of the authors, he shares this experience from a design office back in the mid-90s.
Okay.
He says, Friday was the day the team would send their drawings set to print on the office plotter each week.
Right, the big weekly print run.
Yeah, and these weren't small printers. Huge oil plotters, and they'd automatically fold the sheets.
Wow.
Ready for site delivery first thing Monday morning.
So that physical handover was key.
Totally. And once those drawings got to the site, they went straight to the site office document controller. That person's role was absolutely critical.
What do they actually do?
Well, they'd distribute copies for review, meticulously collect all the markups, the comments, and then, crucially, apply a status stamp. That stamp meant it was formally approved.
Okay, so that stamp was like the seal of approval. This is the one.
Exactly, and that leads to this idea of the drawing hanger.
Ah, the single source of truth back then.
Precisely. The latest approved version of every drawing was stored right there on a physical hanger in the site office. Everyone knew you're only built from that specific set.
It's amazing how that simple physical system really captured the core idea of a CDE, didn't it?
It really did. That fundamental need for one trusted version, regardless of whether it's paper or digital, that's what drove everything that came next.
Okay, so let's fast forward a bit. Late 90s, early 2000s, the internet arrives. Email starts becoming common.
Yep.
Now, CAD software was already being used to make the drawings, right? But the actual delivery was still mostly paper copies.
That's right. And that's when we first saw what you might call the digital paper revolution.
Okay, what was that?
People started emailing PDF versions or maybe DWF versions of the drawings.
Ah, so like electronic copies you couldn't really edit.
Exactly. Essentially electronic pieces of paper. You could print them out, sure, but they weren't the native CAD files.
And the benefits must have been obvious straight away.
Oh, immediate. And huge changes to a design. You could share them in seconds.
Not days or weeks waiting for prints.
Exactly. And that didn't just speed things up. It fundamentally changed where people could work. It suddenly made global project teams feasible for the first time.
Right. Delocalized design.
But here's the key thing. That speed, that very technological leap, it quickly exposed a much deeper problem. It wasn't about speed anymore. It was about trust.
Ah, okay. So the very things that made it faster also created new headaches.
Precisely.
What happened when this digital paper thing really caught on? What were the pitfalls?
Well, suddenly you had critical updates getting totally buried in overflowing email inboxes.
Oh, yeah, I can picture that.
Documents flying back and forth across multiple confusing email threads. And teams genuinely struggled to trust if they were actually looking at the latest version.
Right, which version is the real version?
Exactly. And this lack of clarity, this digital confusion,
Yeah.
it had serious knock-on effects. Reduce accountability, for one. Lots more rework because someone inevitably built something based on an old drawing.
Costly mistakes.
Very costly. Project delays, inflated budgets, often just because decisions were being made using outdated information. It was like a high-stakes game of digital telephone.
A digital Where's Waldo?
Yeah.
For the right drawing, but with real money and time on the line. So how did the industry start to, fix this growing mess?
Well, that chaos, that digital headache you just described, that became the catalyst for the next step.
Correct.
The dot-com boom around the early 2000s saw the first real digital solutions pop up. Things like extranets. They were born directly out of this need for order.
So extranets were the first digital CDEs, effectively.
You could definitely say that. They represented the first proper iterations of a common data environment in a truly digital way.
What did they actually do?
They basically offered a central website, a place where all the different parties on a project could log in and upload their latest drawing sets.
A central digital repository.
Exactly. And from there, the tech kept evolving. You had FTP sites, local servers for a while,
Right.
leading eventually to the cloud-based solutions we see today. Autodesk even had an early product called Buzzsaw.
Oh, yeah, I remember Buzzsaw.
Right. It let designers and contractors securely upload, share, and access drawings. It was an early step in that direction.
It's really interesting how these early CDEs weren't really designed from some grand plan, but just sort of emerged.
Evolved out of necessity, absolutely.
And they matured pretty quickly, didn't they? From just being like useful tech tools to becoming part of international standards. Was that a smooth transition? Was there pushback?
Well, like any new tech, there's always a bit of a learning curve, maybe some initial resistance, but the benefits were just too obvious to ignore for long.
Right.
And this journey towards standardization, it's quite a story. It really kicked off in the UK back in 2002 with something called the Avanti project.
Avanti. Okay, what was that?
It was a British research program, and it was funded specifically to improve how project teams collaborated. They basically looked at the successful practices used when building Terminal 5 at Heathrow Airport.
Ah, the T5 project, famous for its collaboration.
Exactly. They took lessons learned from that. Avanti put together a best practice protocol for how information should be exchanged and managed.
And that protocol became...
It first became a British standard, BS 1192, back in 2007. Then it evolved into something called PAS 1192-2 in 2013.
Okay.
And ultimately, that whole lineage became the foundation, the basis for the global ISO 19650 series we mentioned earlier.
Wow. So it went from UK best practice to a global standard.
Yep. And the crucial insight there is how standardization turned CDEs from just, a good idea, an optional extra, into an essential framework. It de-risked projects, especially international ones, by providing a common language and process. It built trust on a global scale.
That ISO 19650 standard is clearly pivotal then. You mentioned it describes a maturity progression for the industry.
That's right. It outlines a path, starting from traditional 2D information.
Like the old paper drawings, basically.
Sort of, yeah. Then moving through file-based 3D building information modeling, or BIM.
Which most people listening will probably know. Definitely know.
And then the ultimate goal is full object-level collaboration. But the key point is, all three of those stages manage the project's information model within a common data environment. The CDE is the underlying technology layer for all of them.
Okay, the technology layer. So what does that layer actually need to do according to ISO 19650?
Well, the standard, specifically ISO 19651 Clause 5.1.7, it lays out two fundamental requirements for a CDE.
Okay, what's the first one?
The first is the progressive collation of the project or asset information model.
Progressive collation. Sounds like making sure information builds up logically over time, not just a data dump.
Exactly. It means the information has to be managed continuously right across the whole life cycle of the asset.
So during the design and build phase.
Right, what's called the capital delivery phase, or the project information model, the IIM.
And then also when it's being operated and maintained.
Yep, the operations phase, which uses the asset information model, or A. It's about keeping that model alive and evolving.
Got it. A living model. What's the second requirement?
The second, and just as critical, are the information life cycle states. This seems to be the real engine room of how a CDE manages information, making sure it's reliable.
Okay, lifecycle states. Tell us about those. You mentioned WIP, shared and published earlier. This sounds like the core process.
It absolutely is. It defines a clear journey for every piece of information, every information container, as the standard calls it.
Right.
It starts in work in progress, or WIP. This is where each specific team, like the architects or the structural engineers, develops their own stuff privately.
So nobody else sees it yet.
Not until the team leader, the author, decides it's ready to be shared. Once it is, they upload it to the shared area.
Okay, shared. What happens there?
In shared, other teams can see it and use it as a background reference, maybe to coordinate their own designs against it. It basically replaces that old routine, the Friday night drawing issue we talked about.
Ah, so it's visible, but maybe not officially the one yet.
Kind of. It's there for coordination. Then, from shared, the information goes through a formal approval process. Is it fit for purpose? Is it ready to be built from?
The check and approval step.
Exactly. And if it passes that check, it moves to published. The published area is the official, approved, trusted source for site teams and other stakeholders.
Just like the old drawing hanger in the site office.
Precisely. It serves that exact same function, ensuring everyone works from the definitively approved information.
That makes so much sense. It's a really clear, managed flow.
It is.
So bringing us up to today, a good example of a modern CDE platform would be something like Autodesk Docs. Right?
Absolutely. Autodesk Docs is a cloud-based system for document and data management, and it's actually been certified recently for managing CDE processes according to ISO 19650.
And it helps set things up, like those states.
Yeah, it even comes with templates to help you organize your information correctly, setting up the folders for WIP, shared, published, and handling things like naming conventions.
Making it easier to comply with the standard.
Exactly. And what makes a modern CDE like Docs really powerful is that it can serve all the stakeholders, not just during the main project build, but also during the long asset operations phase afterwards.
So it connects everything together.
Pretty much. It provides that underlying file management and, crucially, the permissions control. And it connects to all sorts of other tools in the AECO cloud ecosystem.
Like what kind of tools?
Well, things like BIM Collaborate Pro, which is for the design side, Autodesk Build for managing things out in the field, Autodesk Tandem for the operations phase, even Workshop XR for doing reviews in VR, or Autodesk Forma for really early stage design work.
Wow, so it acts as the central hub connecting all those different workflows.
That's the idea. It's the common thread.
And the scale today is pretty massive, isn't it?
Oh yeah. Autodesk Docs is used every day by literally hundreds of thousands of users across millions of projects globally.
It's all about ensuring that the right person gets access to the right information at exactly the right time.
That's the goal. Streamlining everything, reducing errors, improving collaboration.
So looking ahead then, what's next for CDEs?
Well, the big shift, the next generation, is moving away from files towards granular data.
Granular data, what does that mean in practice?
It means instead of just managing whole files, like a big drawing file or a spec document, you're structuring and controlling the data within those files at a much finer level. Individual parameters, specific objects, bits of information.
Ah, so getting much more specific.
Much more specific. The aim is to make information even more accessible, even more trusted, and far more connected for everyone involved. It's a really fundamental change in how we think about project information.
That sounds incredibly powerful. What an incredible journey we've really traced today. From, literal paper drawings hanging in a site hut.
Right. Seems ages ago.
To these incredibly sophisticated cloud-based systems that are now embedded in international standards. It really drives home how vital CDEs are for actually delivering complex AECO projects successfully, getting everyone working from that single source of truth.
Absolutely fundamental.
It's been fascinating.
Definitely. And maybe a final thought for you to chew on. If we kind of zoom out, connect this to the bigger picture, think about this ongoing shift towards granular data management inside CDEs.
Okay.
How might that not just benefit the AECO world, but maybe completely transform how any industry that deals with complex multi-stakeholder projects manages its information? Could this unlock completely new levels of trust, accessibility, and efficiency in decision-making way beyond just buildings and infrastructure? Something to think about.